All right, and we'll get started. I think this is the last one before the keynote, so time for beer. So this is early detection through deception. My name's Jason Nestor, and it's really all the more I'm going to get into about me. But what we're here to talk about is using deception to try to detect an attacker on your network as early as possible. Deception is a very, very broad topic. You can really get into the weeds with what kind of honeypots you want to set up, what kind of deceptive tokens you want to throw out there. I'm going to talk at a super high level of just the sort of things you can throw in there to catch people as quickly as possible. I'm not looking for academics. I'm not looking to learn about attacker methods. I'm just looking to find them on my network and get them the heck off my network. So that's the sort of stuff we're going to talk about here today. So quick agenda. I'll give you an overview of deception, again, specifically deception with regards to early detection. I'll give you a couple examples. So I'll talk about a couple attack scenarios for on your internal network, and then I'll go to the internet and talk a little bit about how we might be able to use deception to sort of separate the noise of the internet from an actual active attacker, try to catch folks at the OSINT layer, and then we'll hopefully have some time for questions or beer. I've learned a lot today, but today I learned that you can combine PBR and pineapple juice. So they're happy and they'll cheer for you if you go get one over there. I don't know if I recommend it, but it is a thing. All right. So what is deception? Again, for the purpose of this talk, I'm just talking about objects on your network or on your DMZ that are real enough looking that an attacker will try to play with them, but fake enough that they don't actually do anything on your network, and have some sort of alerting built around them so that you know when someone touches them, there's a very high likelihood that there's something amiss on your network. Must look real enough to fool an attacker, obviously, but you really need to make sure it's obscure enough to not confuse your actual end users. You don't want to get your help desk bogged down dealing with deception stuff. Like, I've been trying to interact with this file server for 3 days and doesn't do anything. It's a really fun way of playing games with attackers and making them punch walls. This making your red team swear. One of the highlights of my career was getting a red teamer who had been on my network for several months. A red teamer who I really, really respected from a company I really respect. Caught him after he tried to move vertically, and he was swearing at me something fierce. He tried to move vertically in our network after being there, and I think we had him within 30 seconds. I was sending him pictures of the Dropbox that they had left, and called him. He's like, "You mother!" So it's good stuff, and it's rare for the blue team to be on that side of it. So why would you bother? So your network is your home turf. I would argue that it is probably the easiest defense for you to stand up deception because you know what's real. An attacker coming into your network has no clue. So a little story. I used to work for a large retailer, and as part of that retailer, they were owned by a large venture capital firm. And every month they would get all of their portfolio holding security team on a phone call to just talk about different security stuff. And one of the guys on this team, who honestly, I thought he was one of the best security guys in this entire portfolio, but he made this comment of, hey, let's face it, if you get a really good attacker on your network, it's game over. You're screwed. Show of hands, who agrees with that? You agree with that. All right. Well, welcome to the meeting. I derailed this meeting for about 45 minutes because I completely disagree. You have the advantage once they're on your network because you know what your network is. You know what is normal on your network, or at least it's not hard to discover what's normal on your network. When an attacker gets on your network, at that point, they have to be super quiet to not give up the fact that they're there. To me, the advantage changes right at that point. As soon as they're on your network, the advantage is yours. You just have to use it. It's a fun way of using attacker tools against themselves. Coming to BSides like this and watching some of the red team sessions and seeing what folks are talking about for attack. I always watch those and I'm thinking, all right, so what kind of logs is that going to generate? What kind of activity is that going to create? What are they expecting to be present in my environment for that to work? And then how do I shut it down? Slow down an attacker. We love to talk about dwell time. The more deception you have, the slower they have to go to try to avoid tripping up and really, really do their homework to figure out what's normal. And mislead them with fake news. Again, if they don't know what's normal, you can easily mislead them and control that engagement. I did a Google image search for fake news and an Oompa Loompa came up. I don't know why, but there you go. Also, it's inexpensive. Everything I'm going to talk about today is completely free. So you don't have to go asking for a budget, which as security defenders, how often do we say we can greatly increase our security and I don't need any money? Low false positive. If you do it right, this is one of those few things you can have in your network that if it alerts, you go, holy crap, everyone stop, let's look at this. I don't know about you guys, but I spent a lot of time chasing false positives of IDS and endpoint protection and proxy logs, just stuff that almost every single time turns out to be just benign behavior. Deception doesn't give you that. It's unexpected. Red teamers, I would love to hear if I'm wrong here, but I don't get the impression that a lot of organizations are really doing this yet. Especially older, more established organizations. I think attackers come in and red teamers come in and they expect to be able to, load responder and do some credential spraying and talk big talk of I'm going to have domain admin before I go to lunch. And then they sit down and they're triggering alerts all over the place and you're explaining to them like, nah, everything you're finding is fake. And they go, well, crap. None of my tool set is built for this. It is. It is really a lot of fun. This is one of those times where us as blue teamers get to be creative, and come up with neat ways of doing things and not just buy whatever the vendors are selling today. And this is awfully convenient. So I believe this was released Wednesday. NIST Special Publication 800-171B. This is targeted towards government contractors, so non-federal government contractors doing work on unclassified but critical programs and high-value assets. So this just was released. It's out for comments right now. Has a lot of stuff in it, but Section 313.3E is this NIST saying employ technical and procedural means to confuse and mislead adversaries through a combination of misdirection, tainting, and disinformation. And that's NIST saying implement deception. So that's the first time I've seen that from the government. I think that's pretty cool. It is not all rainbows and unicorns. There are some gotchas, some things you should be cautious of. If you aren't careful, you can confuse your actual users, causing production delays. The last thing you ever want to hear is like your marketing team discovered your fake file server and they've started using it because it has more storage than the real file server or it's faster. And, it's been going on for a month. Externally facing deception may result in some tweets out there saying, hey, did you know that company has a whole bunch of crap exposed to the internet and they're super vulnerable? Guilty. I've set that up and I have had those Twitter comments. So it's a matter of knowing whether or not your company is willing to accept that. So always work with your company before you just go putting things out on the public internet. It can be a tough sell. What I run into a lot when I start talking deception is, it's kind of a new thing. It's a new technology or it's a new concept, which it's not. But we're still trying to lock down lateral movement. This is top of the pyramid stuff. It's free and it's easy and it's low false positive. And I would argue, what do you got to lose? But my recommendation would be baby steps. There's a lot of things you can do that are very, very small and very, very low profile and would have a huge, huge gain to any defense team. And we'll get into those. And it's a boring bullet point, but it has to be mentioned. It is no substitute for just good, basic security hygiene. So I am not up here trying to sell snake oil or silver bullets. So before you begin, get your house in order. This is not my list of, hey, do these things and you are a secure environment. This is my list of, hey, if you do these things, you are well positioned to deploy deception and take advantage of what attackers are expecting to be present. So centralized logging, 100%. If you don't have it, get it. Even if you're not doing deception, if you're not logging, do it. I 1000% agree with what Dave Kennedy was saying at the keynote this morning, that you need your workstation logs. It is not optional. Says the guy with the Splunk sticker on his laptop. I get it. It's expensive. But I would honestly challenge anyone to tell me what's more important at this point. And actually configure those logs. There's lots of great write-ups out there of how you should configure your logs. Don't try to reinvent the wheel, but the way Windows comes out of the box is crap when it comes to logging. So just because you're getting your workstation logs, make sure you're getting the logs you need. And then shut down those easy wins. Disable insecure stuff. LLMNR needs to be disabled in your environment. If it is not, finish listening to my presentation and then go back to work and shut that down. If you can, get rid of NetBIOS, get rid of WPAD, auto detection, get rid of WDigest, all that junk, all that legacy crap that's out there that there's plenty of tools that are looking for it. If you can shut that down, I've had pen testers come into my network and just with LLMNR disabled and some host-based firewalls, they sat down, they plugged in, and like 30 minutes later they said, did you just put me on the guest network? There's no traffic on this network. I mean, they had no idea that they were sitting on my production network. That's not deception. That's just good security hygiene. Prevent bad passwords, summer 2019. There's easy, free ways of doing this. You can set up dictionaries of just words that you should not be using in your passwords. Again, if you do this, you can start using those passwords for deceptive purposes. And please, for the love of God, turn on your host-based firewalls. It still astounds me to this day that there's organizations who aren't doing this. What I run into when people argue with me is God, it just got really quiet. That is so weird. Anyways, what I've run into is they think that they treat their host-based firewalls like they treat their perimeter firewalls, right? Well, accounting needs to be able to talk to these 3 systems, IT needs to be able to talk to these 5 systems, and these firewall rules start getting way out of hand. Don't do that with host-based firewalls. Most organizations have workstation VLANs, server VLANs, printer VLANs, things along those lines. Super simple firewall rule. On your workstations, block communication to workstations, block communication from workstations. Your workstations probably have no reason to talk to each other. That's a 2 firewall rule that shuts down so much of an attacker's playbook. I've yet to see it having an impact on an organization, and it makes things so much cleaner for you from a logging standpoint. It's good stuff. Labs, if you're unfamiliar, that's Microsoft's technology for just changing the local admin password for every local admin on your box. Please do this. Again, it's a simple thing to do. It costs you nothing to do. And when you do it, lateral movement is also much harder for an attacker to use because that local admin password is no longer shared everywhere. Hold on. I'm using notes for the first time in this slideshow. But I got them all. Cool. So enough of that. So I'm going to just dive right in, give some examples. So what I'll do is I'll give some like super high level, here's what an attack might look like. Here's some things that an attacker might do just super early on in an engagement. And then how we might be able to use deception to trip them up and alert us to their presence. Are you there? Okay. So attack scenario number 1, foreign device on network. This is the scenario of the red teamer who was swearing at me. They tailgated their way into our organization. They found a really great place to stuff a Dropbox with a MiFi plugged into it, so they weren't going out our perimeter, and they were on our internal network. So that device is not on our domain. They don't have credentials yet. So the sorts of things they're going to start doing is trying to figure out where they are on the network, try to map that network, try to find some credentials so they can get onto a device that is on the network, try to find some weak spots, some poorly written applications, some vulnerabilities, things along those lines. So the first thing I would expect an attacker to do would be to start trying to map the network via DNS. So just doing some reverse DNSs, looking at what address they were given from DHCP, see what else is on that subnet, see what the DNS server knows about. Blue teamers might right now be thinking, well, cool, that's an easy similar of a single source IP on my network doing a whole lot of DNS queries. True, but that is a race condition. And this attacker, again, was on our network for, 3 months, 4 months. And during that time, he could have sat there and did a DNS query a day, right? I mean, what is your threshold of that is now something I want to sneak in or want to look into? 5 DNS queries in an hour? I don't know. So I agree. That is a very good control and you should have it, but I wouldn't count on it. What I would count on is just creating some A records. Set your DNS scope, separate some blocks of addresses in all your subnets and just put some A records in there. They don't do anything, but let your login know about them. If anyone ever queries DNS for those addresses, go track them down. See who made that request, because it's not there for any other purpose except for to draw attention. It might get a little bit of false positives. What I would say is this might be a really cool way of finding someone on your network who's playing. But for good reasons, this might be a good way to find those quote unquote diamonds in the rough. And someone, I don't know, I just discovered how to run an angry IP scanner and I was looking around. Might be a good way of, oh cool. Want to talk? Want to be mentored? But free, easy to do. So another obvious thing that an attacker will do is bust out Nmap. Pen testers love their Nmap scripts. They're very proud of them. They walk in all brazen and brave and say, no IDS and no IPS on the market can detect our Nmap scans. And they're typically right. And by the way, the reason for that is our attackers have access to the same tools that we are using to defend our organizations, right? Palo Alto IDSs, Cisco IDSs, FireEyes, all that stuff. It's a small pool of vendors out there. So all the stuff we're doing to defend our networks, they have access to this stuff too, and they're able to figure it all out before they show up. So yeah, they'll walk in and they'll go right by your IDS with their Nmap scans. But what they won't go by is a pile of honeypots that are just sitting out there that are alerting on connections. What I run into with honeypots is the more the better. You know, one honeypot, not that great. Thousands of honeypots, that's amazing. But your organization is going to say who has money and time to maintain all that. You don't need that. Link down here is Artillery. This is a tool that Binary Defense Systems maintains. All it does, simple Python script. You configure it to listen to a bunch of ports. You choose them. Ports that attackers are normally going to look for. 445, 3389, 22, 21. You know, you pick 80, 443. Set it up there. If anyone connects to it, it spits out to the text file, the source IP file, a source IP address of who connected to it. You configure your log and you get an alert. What you do is get yourself a Raspberry Pi, configure a whole pile of IP addresses, all those fake DNS records you created, give those IP addresses, and set them on your network to various subnets. So I did some research. It took me a little bit, but I found one guy who claimed to get 4,000 IPs on a single Raspberry Pi before it completely burst into flames. So go to 3,999 IPs. But this is like a $40 solution to get 1,000 honeypots on your network, right? I mean, this is not a honeypot in the sense of I'm going to do academic research or watch what an attacker's doing. This is a honeypot in just the sense that I saw someone connect to this. There's no reason for someone to connect to this. I'm going to go track them down. This is, again, it's a $40 way of getting thousands of honeypots on your network. Hold on a second. Yep, okay. Sorry, I just want to make sure I got all my notes. So every pen test I've been privy to starts the exact same way. They attach to your network, they launch terminal, they open up responder, they minimize terminal and say, I'll check on that later. So if you're not familiar, responder is a tool that looks for broadcast requests of certain technologies. LMNR is the big one, which is essentially someone typoed a domain name trying to get to your file server, something like that. And Windows says, well, DNS didn't know it. I'm going to send out a broadcast. Anyone know have this address? And responder will say, yeah, that was me. And the Windows host will say, cool, I was trying to connect to that file server. Responder will say, great, send me your hash. Windows happily sends the hash, and then the attacker can go crack that offline. That's responder. So first and foremost, shut down those easy wins. If you disable LMNR and NetBIOS-NS, responder is no longer going to do anything in your environment, and that's already great. But since you have those Raspberry Pis out there, go ahead and throw this tool called Responder on there. What Responder does is it sends a LMNR request every 5 minutes. And it lets you know if anyone ever responds to it, because since you shut this down, nobody on your network should ever be responding to an LMNR request. So if you do get a response, you know someone is running something on your environment that shouldn't be running. Again, super, super quick way of catching an attacker. I mean, in under 5 minutes, if they're on your subnet, you're going to see them. And the last bit for a foreign device, and by this time I hope you have them. I mean, if you've done these other things, you have them by now. When an attacker gets to this point, they're done being quiet. But attackers love to look for those weak applications, those weak points. So, Nessus scans, RAR or Eyewitness, these are tools that will just scan your a subnet or a network for web presences and take screenshots of them, and then put them in a nice little directory and you can scan through. So give them some stuff. stand up some old Tomcat applications, old Tomcat manager pages. Pen testers fall all over themselves when they see that, because that's typically code execution right there. Oh, they didn't change it. Admin, log in, upload my WAR file. Boom, I have access to this old Tomcat box. It's probably running a system. So give them some. Non-domain join, stand up an old Tomcat box, let them see it, let them connect to it, let them try to compromise it. At the end of the day, they have just as much access as they have today, or with their other non-domain join box, but now you know they're there. Same stuff you can do with Jenkins. Jenkins has a scripting engine that tends to not be shut down. NoSQL databases that don't require authentication by default. This stuff gets attackers salivating. So put it out there, and then monitor the hell out of it. Fake file servers. Again, SMBv1, null sessions. Attackers see that, they get very excited. Stand up some stuff that's MS-1710 vulnerable. Their Nmap scans are going to see that, and they're going to come looking for it. Let them come and find it, and then as soon as they attack it, you got your alerts. You can go find them. And again, so much artillery. I really don't know why you wouldn't do that. It is such an easy solution to a complex problem. Oh, I lied. There's one more for foreign attack. So 21,000. If you have a knack, if you are doing 802.1x, congratulations, you're top of the ladder in my opinion. Not many organizations, or at least big organizations, have managed to pull this off. But typically what an organization will do is if an unapproved device attaches to the network, that port gets disconnected, they get dropped into guest, or they get dropped into quarantine. Brilliant. But your attacker now knows that they've been had. They can grab their Dropbox and get the hell out of there. I say, give them your deception. Throw those Raspberry Pis on those networks as well. Put some more fake applications out there. Let them dwell. I mean, at this point, you no longer want a short dwell time. You want a long dwell time. You want them to hang out there all day long, trying to break into stuff that doesn't matter. So that gives you a nice way of calling law enforcement, casually finding this person, tapping them on the shoulder, tasing them, whatever you want to do. Because they're not aware yet that you're onto them. Same thing for Wi-Fi networks. What I would recommend here is, if your corporation's name is BSides, you have a BSides Wi-Fi, BSides employee, BSides guest. Put some stuff out there that a lot of organizations might have and forget about, like BSides dev or BSides test, BSides mobile, and things that, I stood up for the development team 2 months ago and totally forgot about it. Let that be weak. Let someone try to attack that or try to connect to that. And start looking for those sorts of connections. Now, you have someone who's wandering around with a laptop trying to get it on your network. Just a note, there's a good chance there your actual employees will try to connect to this too, so there's a little bit of false positive there. And then deception AD domain. So an attacker is always looking for AD. Feed in more AD domains. Give them more domains where they don't know which one is your actual Active Directory domain, and make your honeypot AD domains less secure. Let those ones have the weak passwords and the poor configurations, the default usernames, all that stuff. So attack scenario 2 is compromised trusted systems. So here we're talking more like a spear-phish. They managed to get code running on one of the systems. They took over one of your actual systems. So at this point, they're on a computer that's domain joined. They have a valid login. And a lot of the hunt and searching that they would do initially is no longer really required. So the sorts of things I would expect an attacker to do is first really look at the system they have access to. So we're talking about endpoint deception a lot here. So determine what they have access to from where they're at. Try to escalate permissions if they can. Establish persistence. And then enumerate and try to move. Typically they're going to try to move laterally, but since we enabled firewalls, they're stuck. They're going to try to move vertically. And that gives us way more opportunity to take them down. So yeah, what can we do? This isn't so much deception, although I can make an argument here that you're using built-in commands to deceive them into thinking you're not really watching. So if you were at this morning's keynote, I should slip Dave a $5 or something, because this is exactly what I was talking about as well. So if you're getting your workstation logs, make sure you're getting your command line logs. You want to know what's being executed on your commands. And then start alerting on things. Who am I, netch, reg, those sorts of commands. Things that Bob in accounting should not be running. There's no reason that Bob should be running, and therefore, if it gets launched, you have a reason to go look for it. So a couple of things here. Dave was talking about this earlier today too, but the Living Off the Land's Binaries and Services website, maintained by MOAR, fantastic website. Look at it often, see what's new, and just keep in mind when you're looking at this stuff that, hey, these are weird ways of using built-in commands that are typically easy to detect. Dave called out Red Server 32 reaching out to the internet. Yeah, that's odd. So put in your Windows firewall. Red Server 32 should not be allowed to connect to the internet. If it does, that's going to trigger an alarm. Go track it down. Same with things like CertUtil. So that's a fantastic website to keep it in mind on. The other link there is from the Japanese CERT. This is some older research, but it was really cool. They took a year's worth of research of incident response and started enumerating all the commands that they saw attackers use, all the built-in commands, and at what phase of an engagement they use them, and just kind of summarize them. And I tell you, from looking at it, maybe 2 of those commands are something you would ever expect to see an end user use. So it takes nothing to build out some alerts of, I see these commands get ran, I should probably go check that out. Also take a step back though. Alerting on individual commands really isn't that helpful because there's so many, and it's a cat and mouse game, right, of obfuscation. Start looking at more lowest common denominator stuff. /add, /domain, /delete, look at those command line arguments. I see something with a /domain in the command line argument. I'm curious, especially when it's coming from like finance. That's a command line parameter that is interesting. Strange symbols in the command. We like to talk about obfuscation, string concatenation, things like that. Forget all that. Just look for pluses and ampersands. If you have a command with 3 ampersands in it, chances are it's something weird. Carets in a command, any of those sorts of things. You should trigger an alert on that and take a look. And then just super long commands. You start seeing, I think Dave was even calling out the maximum command line length of, what is it, like 2,000 something? Obviously just alerting on a command that long should be very low false positive and yield some pretty interesting results. I would say 200 characters or more, I want an alert. Oh, side note, strange symbols is a fun way of seeing people putting in passwords and clear text on command lines, like on the -P of a command. You can catch a lot of lazy programmers this way, especially if you're alerting on like exclamation marks. All right. So back to more traditional deception. So attacker, I would expect to look for any sort of stored credentials on the system that they have. So give them some. Top 2 commands there are for interacting with like the Windows Credential Vault. You put this stuff in your logon scripts to just add into and stored passwords. And then you can start alerting for usage of this in your environment. So, stand up a fake web server and let it accept logins from, the credentials that you've stored in IE. Someone sees that, they decide that I'm going to try to connect to that web server and try to log in. You got that alert, you can go track them down. Honeybits and honeyhash are both super cool scripts. Honeybits, I think, is one of the coolest things ever created. This just loads the system up with credentials. Puts stuff in memory, stuff, for Mimikatz or WCE to take on. It'll store stuff for common programs. It'll put things in, like, for PuTTY, FileZilla, things along those lines. So it'll load a system up with a whole lot of interesting and enticing credentials for an attacker to try to pull down. And if you do that, there's low-yield SSH servers out there. There's like Cowrie, for example, that is a deceptive SSH server. Go ahead and put in your PuTTY store logins into this. All it is a box that'll accept logins and just return fake results to commands to keep an attacker busy. If you have these credentials in your system, someone gains access to that system, they try to log into these, into a couple SSH servers, you clearly have an attacker on your network. Like, there's no questions asked at this point. You've got a problem, and you're going to go hunt them down. They're going to look for juicy files. So let's give them some of those. So the link I have here is Canary Tokens from Thinkst. This is, if you haven't heard of this, definitely check it out. They have a bunch more than just token files. But what you can do here is go to their website and say, hey, create me a token Word doc. And it has a tracking pixel on it. And you say, if you ever see this tracking pixel, fire me off an email with this data. And you take these and you throw them on your systems. This is also a good, like, angry maid or evil maid defense. So, and you put these on your systems and your user profiles and certain file shares. And then you just wait and alert if anyone opens these files. I would typically put these at, like, the root of a user profile. Or if you have especially a smaller organization or a more tech-savvy organization, go ahead and put it in your My Documents of your user profiles and do some user training to let your users know what this is for, or tell them it's ransomware related and don't click on it. But, as an attacker is searching your network or searching your local files and they see, mypasswords.doc or, ssns.doc in the HR systems, chances are they're going to look at that and you have access to them. I feel like there was more I wanted to say on this slide, but there's not. So what drives are mapped? So what I like to do here is book in my drive mappings. So say your home drive is H, right? So put a drive mapping at G and a drive mapping at I and book it. And the reason for that is humans will probably go alphabetically. Ransomware will typically goes alphabetically or reverse alphabetically. So as they're enumerating your server or your file system and seeing what's mounted, they're like, oh, gee, we'll start there. Point this to a valid file server, a honeypot, but an actual file server. What I got here, this is some registry hackery to hide a drive mapping from the GUI. I was at BSides training yesterday, and I plugged in a thumb drive for the training. Like, why is Windows not showing the E drive? Oh yeah, I did this for a test. So what this does is it goes and powers in two. So any 1, 2, 4, 8, 16, 32, 64, blah 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 blah, all maps to a drive letter. And whatever you put in there, it will not show up in the GUI. If you go to command prompt and type net use, you'll still see the drive. So someone with remote access to your box will see it, but your end users won't. So, if you map an end drive as a deceptive file server, put 8192 in this reg key, your end users will never see it unless, they're looking at it from the command prompt, which again, you might want to go talk to that user because they might be interested in a career in IT. So fill that up. Put some fake files on there, start looking for access attempts to that server. One thing I will say is if you do this as a drive mapping, do it based on file modification, not just browse, because when people start mapping drives in the morning, they come in Monday morning and plug in their laptops, you're going to get an ass load of alerts and you don't want that. Down here, this is making a recursive directory, meaning if I do like a dir/s to search and hits that drive, it's going to loop forever and ever and ever and ever again. This is just a fun thing to do. If you have like an interpreter shell on someone's system and you do a search, it's going to hit that and it's going to get stuck and you're done. You're going to have to kill that shell. But what's fun is that search will continue on. So one hopes that maybe your end users will go, God, my computer is running like crap. And you come and look at it and like, huh, yeah, someone had something going on here. I think that this might also be a good way of stopping some ransomware. It gets caught in this little web of self-referencing of files. Never tried it, but might help you. Okay. So what can we learn from AD? This is pretty old school stuff, but don't see a lot of environments doing it. But yeah, if you have access to a box that's on the domain, chances are you're going to be pulling down AD. You're going to be looking around. So give them some fake stuff. Again, look at what attackers like and give it to them. Fake SPNs for Kerber roasting. Go ahead and create some. Forbid them from logging in. Give them an enticing username. I like my SQL Server is an easy one to go with because that's very common. Set the admin count to 1 and start searching for event IDs of them using it. If you have an MSSP, make sure that they know you're doing this too and let them know that this is one of those times you call me at 3 a.m. I want to know if you see these alerts. Fake computer user group objects. Right. Oh, you know what? So the fake file server, I meant to say, what I would recommend doing is, what I did is I just wrote a script that grabbed all the file names from my real file servers, file names and directories, and recreated them on my fake file server, and then just filled them with random bits of data to give them some weight to make it look legit. It's a very easy way of doing that. But anyways, same thing with fake computer objects, users, and groups. You have your AD domain, you have your naming convention, especially for like privilege use. Like if you have admin users and you do ADM dash in their username, also create ADM and no dash in their username, or an exclamation mark in a username, or PRIV in a username. And don't let those do anything, but an attacker who just has view-only access to your AD, they're not going to know which ones are real. But you are. So any attempts to use the fake ones, those are alerts that you want to generate. Same thing with group objects. You have ADM endpoint that gives local admin access to your endpoints. Have an ADM underscore endpoint. Have an admin underscore endpoint. Put your fake users in those. And it's all a matter of muddying those waters up so they're not sure which ones are actually in use. Fake domain admins, this is based on your risk profile, but create true to God domain admin accounts that, prevent logins. You set GPO to prevent logon, or, set your logon hours to 0. Give it a crazy password or don't. Give it a simple name, or a name you would expect to see in an older organization. SQL admins or vCenter admins, VMware admins is what I call out, because, you got your VMware admin who showed up a number of years ago and set up VMware 3.5 and said, screw it, I don't want to think about this. I just made a domain admin and now I just log in with it. So it's not an odd thing to see, but create those accounts. And it's another thing that an attacker is probably going to look at, and you can trigger alerts. All right. Does that all make sense? Cool. Now it's time for beer. All right. So that's deception internally. Again, you could do a whole heck of a lot more, but those are things that I would do just to try to trigger that alert as quickly as possible. I work for a large company with a small security team. We don't have time for academic research. I just want to know immediately. I don't want to play around. I just want to get them off my network. And those are things that I would do to get there. I'm going to switch to the internet now and what we can do there. Because I think this is really cool. Now, there's some differences here. With the internal network, again, you know what's normal in your network. You know what to expect. And the internet's just full of crap. So the biggest trick with deception is trying to separate the noise of a real active attacker from just Billy running OpenVAS against your perimeter, or, just typical internet background noise cruft. So, anyone who's ever looked at the logs of your outside router, you see all the garbage that's hitting you all the time. So if you want to do alerts on honeypot access from there, you're going to have a real bad time because it's going to be all the time. So what I would recommend is trying to separate that noise out. And I've done some stuff in the past that I think helped a lot. So I'll talk about that. Yeah, so let's let the trolling begin. I think that covers it. So another great free tool called Port Spoof. It's very similar to artillery. The intended use for this is that you take your file server, right? And so you know what ports are necessary. You want 445, you want 389, whatever. But you set up Port Spoof to listen on every other port, right? So let's say it's a web server. So you have it listening from 1 to 79 and 81 to 65,500, blah, 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 blah. And what Port Spoof does is when you connect to it on one of those ports, it returns what looks like a valid banner for whatever is typically running on those ports. And the whole idea is that instead of firewalling it off, it just makes it nearly impossible for an attacker who's scanning your network to figure out what a server's actual intended use is. I'll admit, I'm way too chicken to do that. I've never done that. The idea of having a production server running without a firewall in front of it scares the hell out of me. I wouldn't do it. But do what you do. What I did do with this is the organization I was working for had a whole lot of external IPs that they were not using, as most companies do, see IPv4 exhaustion. And I said, you know what? Can I use those IPs for my own fun? What if we took a physical box, completely segmented it off from our network, and added all of our unused external IPs to this one box? At this organization, it was a little bit over 1,000 IPs. And then we'll set up Port Spoof on this box and let it listen on everything. And let's see what kind of fun we get. And then just to add some more fun to it, the Harvester is a good OSINT tool for just, scanning a particular organization's IP ranges. But it has a nice word list of typical A-name records you would see. So like link server, Skype, OWA, that sort of thing. So I went and grabbed that. I removed the stuff that we were actually using, and I used that to just fill in DNS records for all these IP addresses I was using. And I said, all right, cool. Now we have this box that is going to make it really hard for organizations or for attackers to find our real stuff. So here's what that looks like. That 34,300 is the amount of unique source IPs that hit this box in 4 hours. So just to be clear, that's unique. So, little Billy running OpenVAS and it makes 10,000 connections. That's one on here. This is 34,300 unique source IPs hitting this box in 4 hours. It was popular. I'm going to cut over here. So these are your ports. I know it's hard to see. Nothing that you wouldn't expect here. 445, 23, 1433. Asterisk is 5038, 80, 3389. That is actually kind of fun to watch, though, because you'll see certain things creep up. About 9 months ago, port 2323 was at the top, That was from Mirai. A lot of DVRs run on 2323, and that was the Mirai botnet trying to find new things to infect. This is geographic locations, so Netherlands, Russia, Vietnam, so you can start to see, where these attacks are coming from. But yeah, 34,300. I had no idea it was going to be that popular. My intended use case for this got shot out of the water when I saw how busy that was. This is just showing, so this is a Splunk dashboard, but it's coming from a next-gen firewall that does app ID, app inspection. So, and it's not worth really going into, but down there are the banners or the app IDs that it was detecting. It's just kind of cool because it was detecting it as, this is Samba, this is web, and so it was at least, what port spoof was doing was at least accurate enough that app ID was picking it up as being legitimate traffic. Here's the geographic map for 4 hours. In case you guys didn't know, the world is full of assholes. And there you be. Yeah. One guy swimming. So, I don't know about you. I look at this and my first thought is we should probably geofence a little bit. Like if we don't need connections from India, maybe we should not allow connections from India. But yeah, this is crazy in my opinion. So it's neat, but so what? So what can we do with this? So if you do have a fancy schmancy firewall, next-gen firewall that you can do some automation with, maybe we start blocking this stuff. So I have a link here for MindMeld. This is a Palo Alto solution, but it's open source. And the whole idea of it is you feed in various IOCs, it'll correlate them and spit them out in a usable format. Obviously, they're thinking you'll use it into a Palo Alto firewall, but it could be used for other things. So you could put that in a dynamic list and say, just start blocking this crap. You know that someone's hitting this, and especially if you're feeding this into your SIM, you can do some mining and say, all right, single source IP that hits 15 ports on a single box or hits 15 IPs, deception IPs, that's clearly someone playing. Let's block them. Make sure you have a firewall that can handle it. This is what I mean when this blew up my use case when I saw how popular this was, because my firewall could not handle that. So that's where you get into geofencing and trying to get your rule sets down. But blocking is cool, except for your attacker knows you're onto them then, and they can start trying to be more quiet or be a little bit more intelligent, maybe do a little bit more OSINT before they attack. So maybe instead of blocking, we go with more deception. Let's build some fake sites, some fake portals, some fake login pages, some stuff that has no business use, but the attacker doesn't know that. And put that on some of these fake IPs. And then, if you're good friends with your network engineers, or if you are a network engineer, perhaps you use this port spoof detection to start redirecting traffic, or to block your valid sites to these source IPs, but only allow them to see this stuff. So, they see your 1,000 IPs that are deception, and then they see like your 5 fake websites, your OWA website, your Skype website, your SSL VPN website, that sort of stuff that doesn't exist, but they don't know that. And I'll get into why that's cool here in a second. Ultra advanced level, and make really good friends with your network guys if you're going to try this, network people if you're going to try this. Instead of blocking the legitimate sites, try to redirect them to the deception sites. So if if you have all your end users going through gateway.bsides.com, and that's your login page to all of your internet accessible resources, have a deceptive gateway, gw.bsides.com. And if you detect that there's someone clearly playing on your perimeter, if they go to gateway, redirect them to GW. I'll admit, I never got this working. I didn't buy my network folks enough beer, but I think it's doable. The docs I read seem to think it's doable. So here's what I did. I made a fake VPN login page. We had a Juniper Pulse Secure SSL VPN, so I said, cool, let's stand up a Sonic Wall VPN. And I'll put into it a fake vulnerability. Now, be very clear, Sonic Wall does not have this vulnerability, but who knows? So it's just a simple credential harvesting vulnerability where if I give you an invalid username, it'll tell you invalid username. If I give you a valid username and an invalid password, it'll return an invalid password. So you know that if you get invalid password, I know your username now. And then so I created that. And what I did is I went out and looked at, what's the average age of the American worker, which is 41, in case you're curious. And I said, what's the most popular names of the American worker who was born 41 years ago? And I created a weighted table in a database of what would be the most common usernames. So Jay Smith is, unsurprisingly, the most common username in America right now. So I created this weighted table so that if you were to try to log in with Jay Smith, you have about an 80% chance that this website's going to say, yep, good username. did the same thing with passwords. I went and, got the Rocky list, got the fast track list, got the common stuff like summer 2019, blah, 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 blah. Put that in my weighted table. And, long story short, if you hit this website with J. Smith and summer 2019, you had about an 18% chance of it returning a completely successful login. And if that happened, I just gave you an MFA prompt that did nothing. And so they thought they had a valid login, but they really had nothing. So set all that up. I also kept track of the results I was giving to people. So if they came back later and tried, or if they tried on other sites, they would get this consistent results. So now you have a list of, so now the attacker would have a list of fake creds that they think that they found. And now you can start searching elsewhere in your environment, especially internally. You give someone thinks J. Smith in summer 2019 is a valid account, and then all of a sudden you see that logging in internally, you got a problem, right? Like, you need to go find someone and get your tasers out. This is also, and I'll come back to this is a great way of giving people a fake username standard. So if your username standard, like most companies, is first initial, last name, make your valid logins on here first name dot last name, or first two last seven, or something like that. Because if someone does manage to, someone thinks that they are getting somewhere here, and then all of a sudden you start seeing that naming standard being used internally, that's also really interesting stuff, right? Or if you see, your actual valid internet present stuff getting those usernames, this is no longer just internet cruft. This is someone actively attacking you. Okay, so what's this actually look like? So I just went out to Shodan, found someone's Sonic Wall and cloned it, and put this backend on it and injected this fake vulnerability. So here they are. We don't actually have a Sonic Wall. Typed in the username, came back unknown username. Gave it a username that came back valid, but invalid password. Invalid password. So Vince McMahon's happy. He thinks he just got a valid login. Happy guy. Or a valid username. So he tries again. He gets the MFA prompt. He thinks he's got full creds now. He's celebrating. He's a happy guy. He doesn't have anything, and on the back end, you should be logging this in your SIM, or your SIM connecting to this backend database, so you know that you have now handed an attacker a full username password combo that's fake, so you can start looking at this elsewhere. One thing, I screwed up one time with this, where I had a pen test going on, and I had just set this up, and I didn't have alerting done yet. And I meant to keep an eye on it because I really wanted to see what the pen tester would do with it if he came across it, and he sure did. But then I got busy. I didn't keep track of my log, so I found out later on the day that he had spent a chunk of time on it, and I felt really bad because it's wasting the company's money at that time too. So I had to call him up like, hey, sorry that you wasted some time on this, but it's cool watching you script it. But we don't have a Sonic Wall. If you're doing a red team assessment, let them do this all day long. But if you're doing like a week-long pen test, you're just wasting your money here because they're not looking at your valid resources now. Similar thing. Outlook Web App has a similar, it's not a vulnerability. I think it's a feature in Microsoft Preliance. So they have a timing-based attack that and I think I have this right, but if I'm wrong, someone correct me. If you give it a valid username and an invalid password, it takes somewhere between 5 and 15 seconds to report back invalid login. If you give it an invalid username, it's instantaneous. So fake Outlook Web App login. You can do this with other stuff, links, Skype, pretty much anything on the O365 world will do this. And it's actually cool because there's attacker tools out here that are built specifically to do this, and this fools them. So exact same website, exact same backend, because I wanted them to have consistent experience. I found this on the Sonic Wall, and I get the same results on Outlook Web App. And all I did was change it to a random sleep when they give me a login that I'm going to decide is a valid username, so 5-15 seconds. So, you start to build out this entire fake world on the internet, and it's fun. And one last thing on this side. So if you're not familiar, Honey Badger is a project from Black Hills InfoSec. What it is a way of trying, it's a little bit of hacking back. It's a way of trying to find out where someone physically is in the world, geographically is. And it's just a little Java applet that you try to trick someone into running. The problem with Honey Badger in 2019 is trying to convince anyone to run a Java applet. And honestly, if you're going to do this, consult with your legal department, first of all, because you are executing code on someone's system, and even if they're bad people, you still need to give them the benefit of the doubt, because you don't want to go to jail. Actually, Black Hills had a guy down here presenting earlier, and he was showing off John Strand's book, the owner of Black Hills InfoSec, his Active Countermeasures. Fantastic book. Totally recommend you read it. But it has a nice little write-up of how to talk to your legal departments about this. The cool thing about doing this for an SSL VPN is because that's one of those few places on the internet today where it's still totally expected for a Java applet to be requested to run. Like, you need to run a host checker, and that's just going to be done with the Java applet, so it's platform agnostic, and you're not using ActiveX controls and things like that. So it's one of those rare places where I could see an attacker being like, yeah, okay, cool. And yeah, you kind of have to give them a little message, explain what they're doing for legal purposes, but attackers are just as bad as your end users. I'm like, yeah, whatever, cool. So again, if you have someone on your network that you're pretty sure they're actively attacking you, this is a good way of finding out a little bit more about them. Deceptive metadata. So on your actual production website, you probably have some PDFs, some Office documents, things like that. All that stuff has metadata that you should be sanitizing before you allow it to go on the internet. Office documents can have insane amounts of metadata. Usernames, full names, first name, last name, manager names, computer names, so you can get your computer naming standard, all that stuff. You can get corporate hierarchies. So conventional wisdom is sanitize that stuff, scrub it before you put it out on the internet. My wisdom is put fake stuff on there. So when I was saying earlier about having fake usernames or fake username standards, this is a great place to put it. So now if you go and look at LinkedIn and say, all right, does my HR representative or does my marketing person, does my finance person have a LinkedIn profile? All right, cool. So they're already disclosing that they're, working for my company. Let's look at the finance documents that we're putting out on the public internet. Let's put their stuff in there. Let's put their name in there. But let's put a fake username standard for them. So let's say, your finance person is Kevin Roman. Hi, Kevin. So his username is K Roman. Let's put Kevin.Roman in there as my username. And then when we go into our database for our fake web applications, if we see Kevin.Roman trying to log in, we now know that someone did OSINT, pulled this data down, scraped this out of the metadata of a Word document, and is now trying to use it. I mean, we just went from OSINT, from just passive OSINT to we know we have an active attacker. And for me, if they hit my website, I'm absolutely giving them a valid login regardless of what they're putting on, and I want them to get Honey Badger on there because I really want to track this person down as best as I can. This is one of the few things I've seen where I think I could get from passive OSINT to identifying an active attacker very, very early on. Spear-phishing credential theft. This is just kind of as an aside. So, you have your gateway.bsides.com website, and it has your login prompt. Spear phishers will clone that, try to phish your company, try to get them to provide your credentials there. First of all, get yourself some MFA, please. So that at least if they scrape those credentials, they're going to have a hard time using it for anything. But Canary Tokens, again, has this really cool idea where you tell them, hey, I want to, they'll spit out JavaScript, and you say, I want to put this on a web page that's always going to be loaded from gateway.bsides.com. You let me know if you ever see this load from a different domain. So someone scrapes your website, clones your website, and they're just being lazy and stand it up somewhere else, don't go through the code. And by the way, obfuscate this. You get an alert letting you know that we just saw this loaded from B5ides.com. You have a problem. You might want to go track them down, get their domain pulled, get their website pulled off the internet. Really cool idea. All right, closing up here. Cat and mouse game continues. Attackers are getting wise to deception. I was at Black Hat last year and I sat in on a session from a red team talking about how trying to detect deception in your environment. Keep learning, keep being creative, keep upping your game, keep coming to conferences like this and seeing what the attackers are doing and trying to build your defenses around it. Frankly, if you got into IT and didn't want to learn, you chose the wrong field. You should have been a DBA or an SAP admin. You got to keep learning. And if you'd like to know more, here's some other things you might want to take a look at. So again, that book, Offensive Countermeasures, The Art of Defense by John Strand, is an excellent book. It's just full of different deception technologies that are out there, deception projects. The Modern Honeypot Network is a cool enterprise dashboard essentially for managing your deception in your environment. Black Hills InfoSec runs the ADHD project, which is essentially, it's Kali for defenders. It's a Linux distro full of deception. If you're rolling money, there are some really, really, really good vendors in this space. And come up and ask me about them. I'd love to talk about some of them, but they are doing some great stuff. And yeah, hit me up if you want to know more. I'm here to talk. Also, I'm a dad, so I love dad jokes. But I think we're towards the end here. But if you have questions, hit me up. Yes, Dave.
How do you prevent your deception techniques using to deceive the attackers from? How do you prevent your deception techniques from affecting your users?
It keeps me up at night at times. So two things to that, and I meant to mention, one of the things that keeps me up, especially when I'm being more cavalier with deception, is am I putting something on my network that might give an attacker a foothold? But yeah, so I think a lot of it, if you don't advertise it, your end users are going to find it. Like your drive mappings are mapped, right? They know that those things are mapped. They're not out there searching for open Samba shares. If they are, again, you should go talk to them because they might be pretty interesting. The websites, the public-facing stuff, that is a little bit trickier, but I say this because there's someone from my company here and he's going to agree with what I'm about to say. You might want to work on your onboarding process. If your end users are searching for stuff on your public domain, trying to find where the hell do I log in when I'm at home, because maybe you're just not advertising properly, and if they're having to search for this stuff. But what I would really recommend is baby steps, especially if you're in a large organization. Don't boil the ocean with this. Start small, do simple things, and get better and better, and test on IT always. Always test on your IT department first, and then take it to HR or take it to finance. But yeah, you got to be careful, just like anything else, right? All right, gang. Thank you very much for your time. I appreciate it.
Real quick, schedule change. Last schedule change, I promise.